microwave broke on Thanksgiving. Yeah, like the worst holiday for a microwave to break. So let's take it apart. Whenever you put the fuse in, it works. It's fine. Once you start trying to heat something up, blows the fuse instantly. So there's a couple things I want to do. One, I want to see if we can find a fault in this. You know, is there a burnt winding in like a transformer, or you know, is there a gremlin in there that we have to take care of? But yeah, I just want to see, you know, what's inside it, how it works, and maybe scavenge some parts out of it for a project I've always wanted to do, but have never been able to do because I can't find a microwave. Let us begin. Alright, so I think it's Great Scott on YouTube that has said this is see a screw, remove a screw, and I actually do like that rule. When you're taking something apart that isn't going to go back together, or it's something that you take apart all the time and you know exactly which screws go where and all that, but we'll just do that right here. I'll remove the outer shell. I have to also be very careful because this does have some hazardous substances in it. Microwave transformers, I have heard both sides that they may or may not contain beryllium oxide, which is pretty nasty stuff apparently, and I'm not going to be crushing it up and snorting it. Electrical hazards. I think these have caps in them, big caps. And getting hit by one of those would not be fun times. Is that shell gonna come off? What if we hit it? Big mess. This appears to be a filter, which smells like burnt food. This also doubles as a ventilation system for over the oven. So it's probably going to have a little bit of smoke damage, I suppose, because God knows how long it's been up above the oven, and you know, if you're cooking hundreds of meals every year, you're going to have a little bit of contamination. Hello? Alrighty. So it looks like I might be able to get this bottom piece off. Yes, indeed. And ew, it's sticky with like smoke residue or oil or something. Because when you're cooking and you see that smoke, that's the oil vaporizing from the food. Like if you're cooking with olive oil or something, and then it collects everywhere. I mean, if you were to scrape near your oven, you'd probably accumulate a little bit of grease, gooey grease on like a razor blade or whatever you use to scrape it with. Disconnect these. Gotta be careful. That was plastic and it was sharp. The metal of this is very sharp too, so I've got to be careful. I've got to be careful. Proceeds to tear apart microwave. Okay, so besides almost losing my hand, things have been going smooth so far. Right now I'm just trying to move this out of the way. This is really hazardous. Got electricity, fan blades, oh, it's oily and sticky. Let me remove this first. That's loud. Alright, get that out of the way. Alright, so we can, some type of blower here, a fan here, which that looks, yeah, it's cooling the Magnetron. Here, let me bring you in closer. Alright, transformer, Magnetron. I think the blower for the exhaust fan, that's probably just to cool all these electronics. Let's see, is there anything weird on the board? Where's the capacitor? Aren't these supposed to have caps? Oh, I see it. It's right back there. Center screen. Okay, so I just made a small discovery. I mean, I already knew that was going to happen, but that stepper motor right there that does the turntable on the bottom of the microwave, I disconnected it. And if I take the turntable microwave key, I guess you could call it, and put this here and put my fingers between the contacts, yeah, that tingles a little. I didn't think that was actually going to happen. I didn't know it was going to generate that much voltage. I've given it some thought of why this definitely failed on Thanksgiving, and I thought about this as soon as it broke. On Thanksgiving, you're cooking a bunch of food on the stove, and what's right above it is the microwave, so this must have failed thermal-wise. Maybe something melted, maybe the enamel coating on the winding melted. I don't know, but that's what we're here to find out. All right, that is the fuse that kept blowing. So we got an inductor capacitor. I think that is a filter. I'm not entirely sure. I'm not any electrical engineer. I just know a little bit hobby-wise. Oops, I was trying to unplug that, and what I think is a electrical noise filter, I just broke the board. This was never going to work again. I mean, we just got it replaced. And the date code on it says September 2012. Only worked for 7 years? It's kind of weird. I think I've seen much older microwaves work for much longer. Kind of shocked, especially since it's an LG. LG makes some good stuff. This is actually being filmed on an LG phone. Now, it's a shame that these are made to basically become trash. Nothing's really built to last anymore, which I do not like. What was that? Oh my gosh, hold on, you gotta see this. I've never seen that before. This little connector has a tiny latch on it. I have not seen that before. I've never seen, I think these are called spade connectors. Again, not an electrical engineer. Alrighty, I do believe I'm able to get this front control panel off. I do see a couple, like, iffy things so far. Let me bring this to you guys. Alright, that resistor center screen, I'm pretty sure it's a resistor. I know that inductors come in that same style package. It looks like on the top right of it, the coating is coming off of it. I'm wondering if those got hot. I know that resistors do get hot. They take the energy and form it into heat. But could that have been our failure point? And also, I found this in here. While I was looking at it closely, it looks like it's a document of some type. Let me see what this is. It's a microwave oven tech sheet. These are all the components that are in a microwave. It even has an absolute humidity sensor, a couple oven lamps, a stir motor. Wait, this thing can stir things? Oh, I was correct. I thought I was correct. That board is called a noise filter. So I was correct. That was an electrical noise filter. I gotta say, I didn't learn that by myself. BigClive.com helped me understand a lot about electronics because that's my favorite YouTuber, one of. All right, there we go. Nice schematic of what appears to be the entire microwave. Get out of here, dirt. Oh, Magnetron high voltage diode. That's the transformer. That's the electrical noise filter. And this looks like this is the Micom board. Let's see. I see a bunch of relays here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 7, 7. So yes, that is the Micom controller assembly. You know, looking at this, it looks kind of simple. I mean, to the average person, they'd probably be like, oh, this looks like it's a algebra problem. Just made another discovery on this Microwave board. Those two resistors right there look like they got pretty hot because the circuit board around them is actually slightly burned. Alright, so after thinking about it for like 2 seconds, this Microwave board, or microwave controller board, whatever, probably isn't the issue. Because from what I looked at the schematic, very little, and I can't really read, I'm not too keen on advanced schematics, but nothing here is going to draw that much current to pop a 20 amp fuse. So my thing is either the Magnetron transformer or maybe even the capacitor. Holy crap, that might be the biggest diode I've seen in my entire life. Hold on, I'm going to show you guys right now. Am I going to be able to? Yes, I am. That diode is probably as thick as a standard pencil. It's in line with that cap. Going to ground? Yeah. Yeah, it is. Yep, there's that HV diode right there. That's the capacitor. Going right to ground. And yeah, it is actually pretty cold out here, so I'm going to have some of this hot AF Slim Jim, which I've already had some, and it's pretty freaking hot, but I had it when it was stored in my car overnight. So now it's actually warmed up to room temperature. Very Slim Jimmy. And he keeps, it's just like, oh, hey. Alright, there's that diode. This thing is very big. I want to take out these blower motors. Kind of in my way. These come out. They lift up. Oh. Okay. This might be handy for something. What's that yellow stuff? I don't know. But yeah, I'm going to show you these blower motors. What I was saying earlier is that anything that like exhausts cooking, smoke, or anything like that, it's going to collect oil, and a lot of it. All right, there is one of them, and you can see the nasty crud on there. And here's the other one, which appears to, well, it does have a little bit. You can see how this just collects oil and any particulates emanating from the food you're cooking underneath it. Ugh. Alright, if I remember correctly, this is supposed to be a thermocouple, and I do believe that is the case because it has this like weird threaded, is that metal? Might be metal. Not sure. It has this threaded cord. Let's see, where does that lead to? Oh, it goes to a black wire. Okay. Yep, that's what it does. That is... Oh no, it has 3 wires. Let's go and take a look at the document. I was wrong. It was the humidity sensor. Sure, it looks like it. The oven thermostat is there. And there's the thermostat there. I want to take that humidity sensor out. Alright, here is the latching mechanism, which also includes these switches. To let the microwave know, hey, the door is closed. Hey, the door is open. Alright. So I basically took a bunch of wires and decided to cut them. It really is not going back together. High voltage microwave radiation, Korea. Cool. Time to take out that thing which makes this a microwave, which is the Magnetron. Not sure if that's heat damage from it But it looks like there's like parts of the heatsink which are bronze, but I'm not sure if that's perhaps oil from food being cooked near it. And there it is. Take that connector off, take this one off, which I don't know what it is, except it's got 2 posts. Don't know. Alrighty. Magnetron. That pink, purplish thing right there, that's supposedly the beryllium oxide stuff. And I forgot to say this before, but when it comes to ceramics or anything of like very hard material, it's probably not a good idea to grind it into like a fine powder and inhale it. Because even if this isn't beryllium oxide and it's completely safe, breathing the dust in would probably not be good for you. This might be a thermostat, or not thermostat, I'm sorry, a temperature sensor, perhaps? It's like gold brass. This looks like a dish scrubber. But yeah, that is basically the heart of this incredible piece of engineering. And this entire microwave is relatively simple. Considering what it does, it cooks food. But there wasn't really much going for it. There's just 3 main parts: the capacitor, transformer, and the magnetron. Alright, so this is basically it. The door is the heaviest part. Chances are that it's got some, I think it's got glass in it. I'm not going to find that out. Shattering that would be a mess. But that's where the magnetron was, where it was aimed. I took that panel off. It's actually got a little bit like a guides in there. Pretty neat. And this panel up here, I took off as well. And it's just got another panel underneath it. So maybe it was an option at the factory to have some type of stir, because the, hold on, let me show you. Except I just freaking tore it. Stirrer motor. And that's right around where it is. So maybe this thing had a stirrer? I'm not sure. I don't know what it... Unless they're implying something else. Like maybe a fan or something? Stir up the air? I don't know. Alright, so about my project. I do have the Magnetron transformer and capacitor. And I want to do a project with them. Simply put, a microwave emitter. No nefarious purpose in any way, shape, or form. But I don't really know how to diagnose that stuff. Like transformer, I might be able to do, or you know, probe around each of the windings. But a magnetron, how do you diagnose that? I don't know. And a capacitor, I'm probably going to need a capacitance meter, see if it's up to snuff. But yeah, if you guys have any ideas on how to diagnose those things, and you know how to wire it up, because it's going to be it's going to need 120 volts at least. If you guys have any ideas on, you know, diagnostics, and you know any ideas I need to know to get this working, let me know down below. Thank you for watching.